Hello everybody, I'm still shooting videos with my phone, but I wanted to go over a challenging repair that I had. This is not the actual board, this is just for demonstration purposes. The actual board is in here, which is a MacBook Pro 2017 touchbar. And as you can see, it's working. I'm loading Catalina. Does have a bad D key. Thank you for the butterfly keyboards, Apple. I'll be taking this to a certified Apple store to get it replaced for free. But in the meantime, let's go over this board and explain what happened. So I bought the machine on eBay, got a pretty good price for it. Probably double my money off this repair. I'll make $400 off this repair. So let me go over what happened. I get the seller told me, first of all, the seller was not the original owner. And a lot of times when you buy stuff on eBay, you get more than you bargained for, and not always in a good way. This was one of those. So as you can see, there is no water damage, like the seller told me. The water indicators, they're all good. All the dots are white. Even though this is a demo board, that's exactly the case on this board in here. The first thing I do when I have one of these boards, and you should too if you work on them, is don't plug them in, just check your rails. These coils are all part of buck converters, and they're going to take the PP bus, and with special switching power supply control circuits, they're going to make whatever voltage they need for whatever circuit. So I check all these resistance to ground, because none of these should be shorted to ground ever, right? Now on the CPU, those rails, they're going to be fairly low resistance, some of them. Some of these newer boards, I've seen the resistance as low as 4 ohms, but don't be scared of that. Some of these other rails, like the 5-volt rails, 3-volt rails, K ohms, thousands of ohms. This board had no problems as far as shorts, but one. And that was the PP3V2 power supply. And here's its buck converter. And I was like, awesome, this is great. That means I got a shorted capacitor or device on the PP3V42, most likely a cap. Caps are the scourge of electronics. They are what fail. And here's some right here. Look at all these little caps. You know, there's caps everywhere on these boards. Caps are an important part of buck converters. They're essential. Here's the buck converter caps for the CPU rails. Very important, must have. So finding a shorted PP3V42 on a non-water damaged board tells me this is going to be an easy repair. All I have to do is find that cap. So what I will do to find that cap, I have some special wires here that are tied directly into my bench power supply, and the only thing this power supply gets used for is inject voltage and a small amount of current to find shorts, because shorts are basically electrons going to ground, not through your circuit, and whatever they're going through will get hot when you give them some current. So this allows me to give them some current. Then I will use my thermal imager here, which is a FLIR 1 on a special mount. And these are designed to plug directly into your phone or iPad, but I got a cable with mine. It makes it a lot easier to just use it with a cable, you know, and plug it in than it does to hold the iPad around. And the nice thing about this is a fixed height. I know what this height is. And I don't know if you've seen these FLIRs. They have a feature called MX distance, because these FLIRs will actually have two cameras in them. One seeing regular video and one seeing infrared, and they superimpose the regular video on the infrared. But as you can see, they're not in the exact same spot. There's 2 of them. So you have to adjust that distance and superimpose them, and you have to adjust something called MX distance. The nice thing about having it on a predetermined tripod like this is I know what my MX distance is all the time, and I could just slide right to it and away to go. So I use this a lot. It's a very handy tool, especially when I'm hunting for bad capacitors, which in this case is what I was doing. So before I even hook these up, I flipped the board over, and here's where I got my surprise. Somebody had taken off the TI CD3214. These chips are responsible for communicating with the USB-C port. They're basically like the one-wire circuit. They will communicate with the USB-C cable and tell the charger, hey, I want 20 volts, and the charger will turn on. And with just one of these gone, and this board has 4 of them, one here, 2 more on the other side. If any one of them are broken, even though the machine has 4 ports, it won't work. Neither port works. And each USB-C port gets its own. But they all do the secret handshake and talk together. If one of them is bad, nothing will work. So they had taken this part off, the CD3214. And in this board, because this hasn't been removed, if you look close, you can see there's glue under these chips. They're underfilled. So we're talking about an underfilled BGA package that has almost 90 pins. This is not for beginners. This is advanced micro soldering to do BGA work on a 90 pin package that's underfilled. This is not a simple repair. You do not remove these on a viable board unless you practice repeatedly on trash. The person who removed this one off this board had obviously not practiced, and they ripped up 4 pads. These are 0.3 millimeter balls. They're the same size ball that's present on an SMC chip. They're very small, and they're no fun. So this is that chip up there on the screen, and the balls that were missing, we had this one, which is not connected. That's why it's black. We had this one, which was ground. So I decided to skip these 2. It's okay if they're not connected. I don't use that one anyway. There's plenty of other grounds that are all interconnected on the chip. We can skip that one. And the reason that was pulled, because they probably pulled the chip up before it was liquefied. And that's the problem with an underfilled chip, is you heat it, and if you don't know exactly what the temperature is, and you don't know these balls are liquefied, you're trying to pull it up, you'll rip them right off the board. And that's what this person did. They also damaged this one here, which is pretty hard because this line ran to here. There's a trace that goes between these 2 rows, goes up, and then it goes into the chip. I had to scrape away part of this trace and run a micro wire from here and create a loop and make a new ball, a new pad. And I had to put some ultraviolet paint in the pad before I did this to fill it level. That way there was no indentation, so that the wire that laid across that I made the loop on, the ball would properly stick to it. This one was also ripped off right here. Oh, I love this trackpad in Windows. This one was also ripped off, and I had to repair this one, same process. And I used the ultraviolet paint to glue those wires down so that I can flow the chip on. Because when you have the chip liquid and all the balls are liquefied, you tap it just a little bit and you watch it jiggle like the old Jello commercials. You see when I see it jiggle. That way you know everything's liquefied and the chip is snapping back into place, then you can get the heat off of it. So I fixed that. And that was pretty tedious. That's good 45 minutes worth of work, 30 minutes worth of work. It's not the 10-minute or 5-minute bad capacitor repair I was hoping for. So I went ahead and I fixed it. So then I went ahead and injected power, and the actual problem showed up on thermal was a bad capacitor right here, right there. And I work on a lot of iPads, and these are the same capacitors that you see in iPad buck converters. And you know, the reason that in an iPad they will have dozens and dozens of these all tied together because they don't have a lot of real estate. So to get more capacitance, you just run more capacitors in parallel, and that's what they do. But in this case, this one was shorted, which isn't uncommon to see. So I pulled that off, retinned, reflowed, fixed that. And this was more, the bad cap was probably the real problem that the previous technician got lost on. And they decided that it had to be this CD3215. And I can't tell you guys enough, when you're working on these boards, do not change a chip like this unless you have proved it with your brain. You don't just, in brain off mode, you don't just change these. These are hard. And you just don't go after these unless you know for sure they're bad. And one of the ways you can check these chips to see if they're bad, which is a very important tip, there's these LDO lines. Let me show you what I'm talking about. And you diode check these LDO lines. There's like 4 main LDO lines on this that you diode check. You check this one, the 3V3, the 1V8, this 1V8, and this LDO BMC. You check these and diode check them by putting your red probe on ground and your negative probe here, and you're looking for a 0.5, 0.6 voltage drop, and you make sure that these LDO lines aren't shorted, they're not open, and these are intercommunication lines, and all the chips are going to be talking back and forth. You need to make sure that these LDO lines are fine. So check these LDO lines on each one of those chips. And it's also really important to have a spare board to compare with that you know is good. You know, maybe it has a bad MUX chip, or it doesn't, you know, it's got some other issue, but preferably you want one that's completely functional with no issues, and you use that board as your roadmap to compare to. And I keep one in my drawer. I've got a board in my drawer right here that I know has a bad LM, has a bad chip right here, and but the board's pretty functional. Other than that, it boots up. So I use this board as my roadmap, my answer key to verify other boards. So you must get on eBay, buy yourself a used board or scrounge a board. You need a used board before you start working on these for customers, because you don't want to be guessing. So just don't change these unless you really have to. And if the customer is using an OEM charger, these aren't going to go bad. The only time I've ever seen these go bad is when someone's using a crappy charger, it's not OEM, and they blow them up. These just don't die all the time. They die because somebody uses a shitty charger. So what happened to this board? Cap shorted, inexperienced technician destroyed pads, and I had to replace this chip because it was missing and fix their work. And the result is I now have a machine I'm loading the latest OS on. But this could have been a 10-minute repair instead of a 45-minute, 1-hour repair. So I want to go over this with you. And here's another landmine with these Texas Instruments chips. Some of these are CD214, if I can get a focus on that. I don't know if you can see the numbers on that chip there. See how that's a C00? Some of these 3215s are C03. They are not interchangeable. You cannot put an 03 chip in place of a 00 chip unless you change them all. So I could put an 03 chip here if I changed all 4 and made them all 4 03 chips. But so you really want to pay close attention to that. The 00s and 03s are not interchangeable. So, you know, it turns out that the one I replaced, I wasn't paying attention on this board the first time. I actually put an 03 on there, and I was like, crap, I had to redo it. But because I had UV painted my jumper wires, I was able to take the chip off, and I didn't have any problems doing that. So here's what I use for jumper wire. This is my solder flux, or not, my solder wick, and I have 2 of these. This one actually uses solder wick. See, it's my solder wick. This one I never wick anything up with. I just rip the wires apart at the end of the microscope, so I have all these little hair-like wires. These are, 46 gauge copper wires, and these little individual wires become my jumper wires. So I always use this one to do the repairs. You know, it's hard if you get the spools. Like here's some 50 gauge that comes in a spool. These enamel coated wires, they're very hard to work with because you got to scrape the enamel coating off of them before they stick. And the nice thing about using solder wick wire is there's no enamel coating on this wire. It's just bare copper. So it makes it real easy to make jumpers and stuff with. It's a great for that. So long story short, you buy something on eBay, you may get more than what you bargained for. You may be chasing another technician who isn't a micro soldering person and doesn't have the appropriate tools, such as a good hot air station or microscope or experience, and they're gonna butcher the board, and then you buy it on eBay and you get their problems. But it worked out. It just took more time, but I wanted to share that with you guys.